This is additional practice problems on ratios, rates, and proportions. So if you need more practice on these topics, hopefully these problems can be of additional help. As always, I would recommend that you do the problems first yourself. So pause the video once you see the problem and then unpause it to see how I solve it and think through the problem if you got stuck. Okay? Number one, the density of an object is equal to the mass divided by volume. Okay, we know that. If you've taken a science class before, what is the mass in grams of an object with a volume of 0.01 meters cubed and a density of 4.54 grams per centimeter cubed? Okay, here you got to be careful with your units. Why? Well, this is given in meters cubed, and density is grams per centimeter cubed. And they even give you this hint over here that you have to be careful with the units. So we got to convert from probably from meters cubed to centimeter cubed so that we can use this density directly. Okay, so how do we convert? Well, if it's 0.01 meters cubed and there is 100 cm in 1 meter, but this is where the units come into play. You don't just multiply by 100 and that's it. No, you have to cube this so that you would get the correct units. This would be meters cubed. That would cross out, and the centimeter cubed. So that is 100 to the third power. So that is 10 squared to the third power. So that's 10 to the sixth power. Move this 6 times. 1, 2, that's 1, and then there's 10 to the 4. So 1 times 10 to the 4. So 10 to the 4 is that. Okay, 10,000, and we have centimeter cubed. And now what's the mass with this density? So this is the centimeter cubed. This is volume. Okay, so 4.54 grams per centimeter cubed times 10,000 centimeter cubed. The centimeters cubed would cancel. So what do we have? We have, move this how many times? 4 times, 1, 2. So 4 grams. Okay, so that is C. Jason and Donnie painted a house and received $1,200 to complete the painting job. Jason painted 4 hours, 25 minutes. Donnie spent 2 hours and 15 minutes. If they split the $1,200 in proportion to the amount of time each spent painting, how much did Donnie receive? All right, so you can just imagine that if they painted the same amount of time, you would split that directly in half. Because Jason worked more, he's going to get paid more, and then Donnie will get paid less. So you would already imagine this is less than half of this, or Donnie would get paid less than half of this, which is 600, which is all the choices, which makes sense. Okay, so how much time total did they spend? They spent a total of 6 hours and 40 minutes. Okay, of that total amount of time, how much did Donnie spend? 2 hours 15. Okay, so you probably want to convert all of this into minutes. So this is 120 plus 15 minutes. So that is 135, right? And this is 360 plus 40, that's 400 minutes, okay? So 135 over 400. Now, let's not simplify because now we're going to use this this ratio, and multiply it to this 1,200. Okay, notice this is unitless. So this simplifies to 3, so 300 plus 90 plus 15, what is that? 405, right? So this is how much money that Donnie gets, 405. Again, the idea was take the total amount of time that both of them spent. Again, just imagine if they both spent 2 hours, 15 minutes, then 2 hours, 15 divided by 4 hours, 30, that's half. So they would both get half of this amount. Or similarly, you're going to just add up the total time they spent in total, and then just take the ratio of that with the amount that just Donnie spent. So 2 out of 15 over 6 out of 40. Okay. The tennis balls in a bag are either white or yellow. If the ratio of white balls to yellow balls is 3 over 10, which is the following could not, let's underline that, not be the number of bags in a ball. So this is 3 to 10. So every 3 white balls, there are 10 yellow balls. So you can just imagine that there has to be increments of a multiple of 13 by that simple example right there. Every 3 white balls, there are 10 yellow balls. So which one is not a multiple of 13? This one clearly is. Cross that out. This one is. I blanked for a little bit for some reason. Cross that out. This one is times 3, right? So the answer is D. Okay. Pretty easy for that one. We were able to think through that. A car is traveling at a constant rate of X miles per hour. How many miles will the car travel in Y minutes? Okay. So constant rate of X miles per hour, okay, which is equal to, so in Y minutes, so in 1 hour, there's 60 minutes. So this, again, where the units can help. The hours would cancel, so you have X miles per 60 minutes. That's the rate or the speed. It's just instead of miles per hour, it's miles per minute. Okay? Now, X miles per 60 minutes times Y minutes. The minutes would cancel, so you're left with XY over 60 miles. Okay. Again, use the units to your advantage. A tree is 8 feet tall and grows 8 inches each year. In how many years will the tree reach a height of 30 feet? So there's probably a lot of ways you can approach this. You could just use a linear model, right, over here. It's initially 8 feet, and then it grows 8 inches each year. So let's say each year is X. So when no years pass, X is 0, you have the initial 8 feet. Actually, we got to be careful with the units because this is in feet, this is in inches. So let's redo this. 8 plus the slope or the rate of change is how many inches are in 1 foot? 8 over 12. Because there's 12 inches in 1 foot. 8 over 12 x, okay? And we're interested in how many years it takes for it to be 30 feet. Okay, so 8 over 12x is 22, right? By the way, this 8 over 12 you can simplify to 2/3, right? So x is 22 times 3 over 2, which is 33. It will take 33 years. Yep, that's right. I was just checking my answer. Okay. Aaron reads X pages of a science fiction book in M minutes. If he continues reading at this rate, what will be the number of pages he reads in 20 seconds? Okay, so again, be careful of the units here. So, what would be the number of pages he reads in 20 seconds? Okay, so the rate is X pages. Again, use the units to help you out if needed. I like to do it because it helps me check that I'm on the right track. Minutes, and how many minutes are or how many seconds are in each minute? So in 1 minute, there's 60 seconds, okay? So the minutes would cancel, and then times 20 seconds. Okay, this is the rate, and this is the time. So the quantity, the number of pages, is, the seconds would cancel, so we have X times 20 over 60 This is pages. So the m's would cancel. This would be just 3 on the bottom. So X over 3, or A, 1/3 X. Okay? If x over y equals 1, what is the value of x minus y minus 1? So can we solve this in any way? Well, okay, so this one, let's multiply y on both sides. So x is equal to y. Okay, so x minus y is equal to 0. I moved this y over because I want to make it look like this, x minus y, right? Okay, now what's left? I need a minus 1 on this side, so subtract 1 on both sides. X minus y minus 1 equals negative 1. Answer is A. In a certain room, the ratio of males to females is 4 to 5. After 8 males enter the room, the ratio of males to females is 6 to 5. What's the total number of people in the room before this additional males entered the room? So we probably got to set up a few equations here. So let's say m is the number of males initially, f is the number of females initially. So m over f is 4 over 5. That's what they tell us. Ratio male to female is 4 to 5. So after 8 males enter the room, so m plus 8 over the number of females didn't change, okay, equals 6 over 5. Okay? So we are interested, what's the total number of people in the room before the 6 additional males enter the room? So we're interested in m plus f. We got to find what m and f are. Well, unless we can symbolically find what m plus f is from these two equations. That might be doable as well. Okay, so how do we solve this? Well, 2 equations, 2 unknowns. This is a system of equations, is it not? So we can write this as this second equation as m over f plus 8 over f is 6 over 5. Why do I want to do that? Well, m over f equals 4/5. So 8 over f is, I'm just going to move that over there, 6 over 5 minus 4 over 5, which is 2 over 5. Okay, so 40 is equal to, I'm cross multiplying, 8 times 5 is 40 equals 2f. F is equal to 20 then. Okay, so if f is equal to 20, then what does m have to be? So let's plug it in. M over 20 is 4 over f. You can plug into this one, by the way. Doesn't matter which one. System equation. Okay, so if I multiply 5 on both sides, this would be a 4 over there. So m is equal to 16. Okay, so 16 plus 20, 36. Answer is B. Person is born every 5 seconds and a person dies every 12 seconds. How many seconds does it take for the population to grow by 1 person? So I'm thinking that 1 person is born every 5 seconds. So how many people are born in 1 minute? There are 12 people every 1 minute that's born. Okay, similarly, in 1 minute, how many people die? That's 5 people over 1 minute, per 1 minute. Why do I want to do it like this? Well, these rates are a little hard to compare right now because this is born every 5 seconds, dies every 12 seconds. Every 5 seconds versus every 12 seconds. So I'm going to scale it up to per 1 minute. That's the least common multiple, if you noticed. I think that's the least common multiple. It should be. Or I just multiply them. That gives you a multiple right away. So now this is easy to compare. So in 1 minute, 7 people is a net of 7 people. Net growth of 7 people, right? Because 12 people are born in 1 minute and 5 people unfortunately die. So there's a net growth of 7 people per minute. So how long will it take for the population to grow by 1 person? So now we just got to scale this down now. So we're going to divide by 7 on the top and the bottom. So it's 1 person or 1 people, so over 1/7 of a minute. So what's 1/7 of a minute? That's 60 seconds over 7. Okay? And what is that? That is 8, right? And 4/7 seconds. So then that is B. Yes, okay. Okay. Steve is going to paint a wall that measures 9 feet by 12 feet. If 1 gallon of paint is needed for each S square foot of wall and each gallon costs G dollars in terms of S and G, how much does it cost to paint the entire wall? All right, so again, use the units to your advantage if needed, okay? What's the area of the wall? It's 9 by 12, okay? So the area is 108 feet squared. 1 gallon of paint is needed for each S square foot of wall. So 108 over S, this is the number of gallons needed. So maybe let me write this. 108 feet squared times S feet squared, and that's 1 gallon. Again, this is how we use the unit analysis to help us out, okay? And each gallon costs G dollars. Okay, so the gallons would cancel, the feet squared would cancel, so you have 108 G over 5. Or sorry, S, that's an S, not a 5. So that is D. Okay, so hopefully you see that I emphasize using the units to help you out. If 2 inches is equivalent to 5 centimeters, how many square centimeters are in 1 square inch? So you gotta be careful to convert again. Okay, so we again use the units to our advantage. So if 2 inches is 5 cm, if we square both sides, 4 inches squared is 25 centimeters squared, okay? How many square centimeters are in 1 square inch? So you gotta divide by 4 now. So 1 inch squared is 25 over 4 centimeters squared. And this should be acceptable if you need to put it in decimal. What is that? That is 6.25, right? Centimeters squared. So 6.25 is also acceptable. Again, I don't know how the digital exam works nowadays, but in the past you could bubble in fractions like that. A large painting has a length of 18 inches and a width of 12 inches. Each dimension is reduced by x inches to make the ratio of the length to width 5:3. What is the value of x? Okay, so what is 5:3? The length over width. So 18 minus x, the original length, minus the x inches over 12 minus x. And we just solve for x from here. We can cross multiply. So it'll be 5, 12 minus x is 3, 18 minus x. Okay, so what is this? This is 60 minus 5x. That is 54, right? Yeah, 54 minus 3x. So what is this? This is 6 is 2x. X is equal to 3. Yep, that's right. So the setup was just like this, and then was just algebra from there. All right, that's it for this practice set. Hopefully this was good practice for you if you needed it, and hopefully I was able to clear anything up as I was solving them live here. And as you notice, again, I constantly use the units to help me out, to see I'm on the right track at the very least. All right? Please like and subscribe as always if you found this video helpful in any way. It greatly supports the channel.